battery to it, it can cause it to not hold the circuit as well. So, all right. So play around with this. Have fun with it, and then after you try this one with the putting the battery on, then try the larger 1000 one. I'm going to switch out my LEDs because I had a bad light a while ago and I forgot to take it out. So let's see, LED 4E is my positive and 4F is my negative. Let's try this and let's see if it just fixes it real quick. Yep, it did. So I just need to discard that light. It's no good. Alright. So, it may have worked without the capacitor a minute ago. So, let's change it out. Let's unsnap it from the battery. Let's change it out. I'm just out of curiosity because that was bad. I just want to see if it worked for the other one. I can't remember. Yeah, it did. But is it out as full? Is it as bright as it could be? I don't know. Let's try it. So this is just with the battery. I hope yours worked. Sorry, y'all. Now let's try it with the capacitor. 17F is my positive, so 17F positive, 17E is my negative, and let's try it. Yeah, it's about the same, isn't it? So it is getting about the same. Okay, and then we're going to take this off, this capacitor. Knock it up a little bit. And then we'll add in the 1000 micro units. Positive is 17F and negative is 17E, which would also be better for me to be saying the anode cathode, okay? Okay. And then let's try it to the battery snaps. Alright, and then we could, so it's supposed to be where, and I had trouble with this when I built it before, it's supposed to be that the capacitor holds, stores the energy. Remember I talked about it kind of looks like a glass or something that could hold something. Okay, so cup or whatever that could hold liquid. Well, instead this capacitor holds energy. So I'm thinking if I left it hooked up to my battery and it could pull the energy into the capacitor, when I unplug the battery, there should be enough energy to let the LED slowly go out. But I've not had mine on very long, so I'm assuming that's why when I unplug my battery, it automatically drains it. But I'm going to try it one more time. Nope, still goes. So I will say this at home. When I turn off my lights in my living room where I have LED lights, which most of us probably have LED lights, when I turn them off, they do not go off immediately. It still holds. So that lets me know that they are holding energy, and so there must be a capacitor in there for them to store that energy and them to not go off right away. And that's the way this should be. So I really feel like if I left this on and let this capacitor build up the energy, store the electricity in there, then the light, when I unplugged it from my battery, it wouldn't go off ASAP. It wouldn't just go off as soon as I unplug it. All right. Well, this is lesson 8 on capacitors, introduction to capacitors. I hope you've learned a lot. You have come to the point where you have learned so much about resistors and capacitors and batteries and how to use a circuit board that you can start experimenting with these different things that we've learned and see what you can come up with. Just remember that you have to have resistors in order to not burn out your LEDs. Okay? All right. Happy learning. Thanks so much. I hope you subscribe so you can get the next videos.